Okay, good morning, guys. It is Tuesday. Yeah, Tuesday. Sorry, this whole being home thing is really weird. As you've seen in the other videos, it's certainly harder for many of us because teachers aren't available, and for us educators, many of us have our children running around uh, like crazy. So bear with us as we're dealing with this process, and let us know if we have any questions. So here is the answers. Now I did post them. I just want to talk a little bit about this. I can't really add a whole bunch here in terms of drawings, so I'll do my best. I've put most of those drawings on this as well. Uh, these are really good web pages right up here. Yeah, okay, cancel. Right up here towards the top, if you wish to learn more about this, or if you're still confused. So this is all about total internal reflection, which only occurs when we surpass the critical angle. Okay, remember the critical angle itself is 90 degrees of refraction in that second medium, and that second medium must be less dense, as we see here. Okay, so by the hand, we have to go from a more to a less dense medium because it needs to be bending away from the normal. All right. Um, with that in mind, it has to go from more to less dense, and it has to go from slower to faster, and that's because less dense mediums uh, cause light to travel faster. Remember, the angle of incidence are going to be the greatest here, and also remember that the refractive angle is 90 degrees. Okay, so I know it says it's confusing. The angles of incidence are greatest and the refractive angle here. But because of that, that is where we're going to see the most internal reflection when we surpass that critical angle. This is a better diagram to really show if I were to hold a laser at angle A and slowly move it to meet these angles, what would those rays look like? First of all, at A, it is the closest to the normal. It will still bend away in air because it's less dense, but it would be the most intense. The closer you are to the normal, the more light in terms of intensity travels through into the next medium. All right, less of it is reflected, most of it is refracted. But as you move further towards D here, we're increasing that angle of incidence, which means more of it is going to be reflected. And I've kind of identified this with the arrow length here. Okay, so we see A would end up seeing more enter the second medium and less reflect. Now, as we get close to this critical angle, looks like C is going to be very close to the critical angle because it is almost 90 degrees. Once we surpass that, we do not get any light traveling into the second medium up here. It is all reflected. That is total internal reflection. So we must meet the critical angle first before we can have total internal reflection. Now that's important for this next page as we talk about the princess cut or the perfect cut for a diamond. For number 8 up here, it asks circle all that apply that would undergo total internal reflection. And we know that the critical angle is 46 degrees. So the first thing we ask ourselves is what diagrams go from a more to a less dense medium? And that is A and B. It can't be C and D because it is not going from a more to a less dense. It's going from a less dense to a more dense. It would bend towards the normal and therefore would not be able to meet a critical angle. Then we need to look at these angles. This appears to be about 45 or right around 46, which means it would just be critical angle, just be a critical angle for that second ray, and we would see very little reflection coming back into lucite. Once we surpass that critical angle, no light will enter the air. It will all be reflected. So diagram B, the angle of incidence is greater than 46 degrees. So we would see total internal reflection. Now for 9 and 10, I just threw these questions in. Remember that most of the critical angle calculations yield 1 at the top. If we look at this first one, air tends to be a less dense medium we move into, and the critical angle is always 90, and remember, sine of 90 is 1. So most of this does cancel out and gives us 1, but you have to be careful if we're going for, like down here, water and glass. We're actually going into a medium that has a refractive index more dense than air. So this wouldn't yield 1 on the top. So take a look at these solutions, but really I want to focus here on B, C, and 11. So according to 10, we calculated this critical angle of 38.3 degrees. So if I were to hold a laser beam along this in a diamond, I would not really see any laser beam enter the glass. It would kind of follow along the boundary here. And then if I were to move that laser and surpass 38.3 degrees, maybe go 40, 45, 50, I would see total internal reflection. All of the light would be reflected back along the boundary back into the diamond. And that's the importance of this diamond cut. The true diamond cut is actually the sides, and it yields total internal reflection because incoming light follows down the normal on the top. And then it reaches the side wall, if you will, of the princess cut, and the normal line is kind of here. So it surpasses the critical angle, meaning that its total internal reflection hits the opposite wall, which has the same angle, total internal reflection again, and then all the light comes back out. So it allows light to enter and then be sent right back out. Nice bright light, lots of reflection, lots of sparkling going on here. So this is the proper cut. These are the expensive diamonds. Now, some people obviously try and work their way through a large looking diamond and sacrifice money by cutting off portions of it or have a cheaper cut diamond. And that's actually not a very smart, or for a pun of the day, but not a very bright thing to do. Because if you remove this section, the light will travel straight through. It would pass through what is now the new bottom of the diamond, and it would just go into your finger or the ring itself. It would not be able to bounce back. The only light that might be actually reflecting would be light entering here at a side angle, hitting this boundary, and then reflecting back out, where this properly cut, all of the light is being reflected out. So by removing the bottom, the ring isn't going to look as sparkly, it's not going to look as bright. It might be a much larger diamond, but it's not going to sparkle and therefore not draw attention. So gentlemen, make sure you get the right cut diamond when you're ready to cross that bridge and propose and pop that question. James is going to say hi, and I'm going to sign off. James, can you say hi?
Hi.
What do you say to my physics students?
Hi, I got spongy.
He's got a sponge.
Sponge.
Yep, and that's it. All right, guys.
Spongy. Spongy. That's us learn.